right, my friends, let's take a look. This is kind of a warm-up for the warm-up. The ratio test is something that we'll use in a couple different in a couple different ways, and you're going to want to make sure you feel like it's true, not just that I told you that it's true. I hope that makes sense. So anyway, so let's get started here. So this first one, your first term would be 6, that's what they're telling you there. And then if it's a sum, we'll be adding the terms together. And then you just keep multiplying your first term by another 2/3. So that's what this part is saying, is to take any term, multiply it by 2/3, and you get the next term. So, so the third term would be 6 times 2/3 squared, and so on. And so I hope it makes sense when you look at this. You can see it's an infinite geometric, and its common ratio is 2/3, which is between -1 and 1. And so we would say that it converges. It's a convergent geometric. And we're saying that because your common ratio is 2/3. Okay, now let's look at part B. Part B says a sub k plus 1 is 1 times a sub k, and your first term is 1/2. So this would equal 1/2, and then you just keep multiplying by 1 to get the next term. So technically this one is also geometric. It just happens to also be a constant function for the terms, but this one with a common ratio of 1 is a divergent geometric. Since if you added up all the terms, you would not get something finite. So that common ratio of 1 would cause this one to be a divergent geometric. Now for part C here, your first term, it says, is -1, and then you're supposed to just keep multiplying by 2 to get, the next term. So you'd be adding, I guess, a -2, which I guess I'll just write -2, and then multiply that one by 2. So that's what that one would equal. And it also diverges. So it's also, it's a geometric series. Its common ratio is 2. So it's a divergent geometric. So what I'm trying to show you here is how to recognize when something is geometric if it's given in recursive form. So, so hopefully that part's making sense there. And then look at the form of the rule here. So geometrics always kind of have this look of basically saying, hey, look, to get from one term to the next, you just keep multiplying by the same thing. And depending on what that thing is, so the common ratio of 2, 1, or 2/3 would affect whether you have something that, that converges or diverges. So hopefully that makes sense. Okay, now here's warm-up number 2. It's another just think about it type thing, but we're going to be using, some kind of jumbly looking math notation. And I do want you to take this time to see if you can figure out what the heck it's saying to you, okay? So after that first warm-up, you're a little more primed to kind of follow what's happening here. So just think about it. You don't especially have to write it unless you want to. But one of the following conditions down here, A through D, one of them guarantees that a series will diverge. 2 conditions guarantee that a series will converge. And 1 actually has no guarantee at all. It could go either way. So see if you can figure out which is which, and see if you could actually find some words that would explain why you're saying this, okay? So really right here, this is giving you a chance to understand the background behind the ratio test. So take your time and then check in with me in the next video.